Okay, yes, so it does work. I have RStudio open. I have an R Markdown file that I was working on recently. All the machine learning packages are right in here. I also have dplyr, tidier, and lubridate because sometimes I work with dates and grouping and arranging the data. These files can actually be found in GitHub, but let me just get to what I'm going to talk to you about today. I've uploaded some data tables to Kaggle. If you want the website, I could give it to you right now. Let me just open up Notepad. And then you'll have to pause the screen while I copy and paste it in there. Wow. Oh, right, yeah. Okay. No, don't. Okay, so this is the lag one, which means it shows the previous day prices. What I've been working on is to predict the next day prices, also predict the currently ran day on number of days increasing or decreasing in a cycle for 65 stocks that I have pulled from Yahoo Finance. And this was in a different R Markdown file, but let me just get that website for you real quick. Okay, yeah, so here's the Kaggle one. This one is for the stock day counts increasing and decreasing 65 stocks. You can also see, let's see what's in it by going to RStudio, and we pulled in this file. There was a program that got the lags of these stocks, the start date for when their time began, merged all of them together, and then found the number of times that that stock increased or decreased as a cycle based on the history, well, based on its time series history, going back to as far as 1999, as the file was written out from January 1st, and then the today date was at that time March 15th. It is March 18th. So the great thing about RStudio is that you can look at your files in the bottom corner. You have your environment here, and these variables are actually from the other R Markdown file. This one's for the machine learning, stock count 65. You can find this all in my GitHub account right here. Let me copy and paste that into Notepad, pause, and you'll see it. It's in that folder. There's actually a whole bunch of files, and stock count 65 R Markdown. That's machine learning for the 65 stocks. I couldn't upload the data sets because they're larger than 25, so you would have to go to Kaggle for that. And they're all less than 100 megabytes. They're about 60 in average. Return on investment, that was the first one where I picked the stocks, and then this one has an automation. All of these R Markdown files are there. And the lag counts increasing, decreasing, that takes you through what each of those are. Let me go ahead and do that. I will look at the files. Okay, so the matrix automate date lag stocks, that should be in GitHub. And it is, but it is right here. Go to the second one, and I'll go ahead and pull that one up. Okay, yeah, so I have the automate date lag stocks too. I usually put a subsequent number after it for which sequence in time it is a extension of the first file. This is where I actually add in all of the information. I also made an R PDF file of it, which you can easily view the results in. It will be 130 pages because it includes all of the fields and stuff, and the code to get there. But I just wanted to talk briefly about what this does. Okay, so if you run this matrix automate file, you enter in the date, and it will take, so you enter in quotes, the year, month, and day. This is January 1st, 1999. and you do the lag. In this case, it was 15, but you could easily do 1 for the day before, 7 for a week before, and then what you're going to get out is going to be a file, and we're going to name it all 65 stocks, count groups. It's going to have the date you requested, then today's date, and then the lag number, and it's going to be a CSV. So for this one, it was all 65 stock count groups, and it was the lag 15. I'm just going to tell you what it did. View this file. I mean, it's thousands of lines of code because it's a lot of copy and paste to get everything the way it is so that it can combine these 65 stocks that have had each one separately added a lag and then a group count by numbers to take you through the code. This stock CSSEP. Okay, let's just open up this one first. It's actually in this table because it was the last one used. I'll pause it though. Let me just read. Okay, so I read in the file, and it's the 65 stocks. You can see it's organized by stock name, and the stocks go from American Airlines to ExxonMobil. Those are the stock names, and there's 65 of them. The date's not all the same for every single one because some of these don't have a history as far back as 1999. This is Crowley, Mr. Crowley. He's a tough guy. And so this one does. It has a start date 1999. Now, if we go up more, we'll see that some of them don't have a start date of 1999. Like this one, 2001. And that would be Advanced Auto Part AAP. So in the code, the matrix automate date, it provides everything to build this table, and you're pulling it from Yahoo Finance. You have to put in the date you want, and every date after it up until today's date will be pulled. You specify the lag number. This would specify 2 weeks before, and it will cut off when you do complete cases those dates that have NAA values. And the packages used, these are the packages: Quant Modern Performance Analytics, and it pulls from Yahoo stock basket right there. I just want to go over real quickly though what the point of these cumulative counts are, because in probability, if there's a number of times based on, let's say, the month, the year, the month, year, day of week, that there are more likely increases in a cycle, like it's going to continue to raise or fall, then it will take that into account when predicting. And so you can see this is a logical if today by lag 15 price. Don't the start day and the final day, those are just letting you know when this information was available, pulled for this stock, and when the lag 15 was applied. The actual stock day value gives the today's price, and it's in October 2019. The actual date is October 6th. I'm sorry, it's October 2009. October 6th, 2009. That's the stock day value. And then you'll see the lag value from 15 days earlier was 6 cents. Didn't really do anything. Is today greater than lag 15? 0 means no, 1 means yes. We can go to the 1 dates and see how many times did this cumulative sum today greater than lag 15? And this is Mr. Goody. He's a sweetheart. And so we're gonna go to, this is what I was talking about. So it's a no. How many times in this cycle from the start cycle date May 5th, 2000 to March 13th, 2020, did it, within a 15-day price period, the ratio today to lag is 1. It's exactly the same right here, right there, stock day value lag 15. Today greater than lag 15. Okay, so this is saying it's doing a cumulative sum. So it's saying how many days in a row, whenever it repeats, that's actually what I'm taking of. It repeated. So the cumulative sum today greater than lag 15 is 224. How many times did it repeat? 44 times. That means because whenever it's not greater than 15, it's decreasing or staying the same. And it did this 44 times at 224. So whenever it was 224 days greater than the price 15 days earlier, it did this 44 times. So it would increase. It had a cycle of 44 times. This is a hidden information, kind of like hidden layers in a way, but not really. It's more like meta because it's not putting the function through anything. And then what it actually calculates though is the decreasing days of the cycle, because that's how many times it repeated. But then, like the pigeonhole principle, you have to count the day that it actually, you can't count that day. So the decreasing days of the cycle, 43. The number of times decreasing day counts occurs is 1. So it only had, in its span from 2000 to 2020, which is 20 years, it's only had a cycle where it decreased 43 days, or it was equal. It decreased or was equal, no change, 1 time. But there are other days where it does this. Let's say the number of decreasing days is 76. How many times did it decrease? This is a different stock. We'll just show you. King Gold Jewelry. And that one, okay, so 76 decreasing days. It only did that twice, but it's more than once. So twice in 20 years, it decreased for 76 days, or did no change. And it keeps track of today. Is today less? Now it's going into the less, and this is counting the number of times that it's had increasing days. So in repeats 3. At 348 days, it repeated 3 times when it was less than lag 15, which means that it wasn't less than lag 15, so it's keeping track of when it was larger, the price was larger than 15 days ago, and it did this 3 times. The number of increasing days, that cycle was 2. How many times in this span of 20 years, or whatever the stock has, did it have 2 increasing days? 46 times. The code is in here that does it. It's RStudio. For each stock, there's 65 of them. It pulls this information. It uses the dplyr group by and such. But let's get on to the machine learning. So now I've explained this. If you have any questions, go ahead and post it below the video. I actually never check, but maybe someone else will. All right, so we have that table. Now then, we're reading in this table, but it's the lag 1 table. We'll pretend it's the lag 15 table because I made 3 different tables. You can find those in Kaggle. Feel free to explore these tables. Sorry, that's the lag 7. That's the price 7 days ago for stocks. And then you have getting a bit slow. Okay, so machine learning. So I'm talking to you like you're my little niece. Okay, so you could be my little niece. All right. So pull in the table, get the information. We're going to create a subset for each stock. So we're going to actually make this a little bit bigger now because we want to start those. These are actually from the other program. I just never erased it. But I can do that now. So we'll go ahead and do that. We'll erase this. I use some machine learning to find out on one subset. And you can do this with all 65 subsets. I'll show you. So we have these machine learning packages right here. Generalized boosted machines, mass, random forest, the carrot package, which I will use for generalized linear machines. I actually didn't use the GBM, I can take that out. Also for random forest, I didn't even use the random forest package, but carrot does a host of machine learning. And so does the mass and E1071. I think those are dependent. Other random forest is dependent on that. Labor data is for dates. Tidier is for gathering or separating the columns as needed. Dplyr is for the group by functions. Okay, so let's just go ahead and put in all of our libraries. And then we'll use the stocks. The version information will be when you run it 3.6.2, dark and stormy night. Let's look at the stocks, the first 5 columns. Scroll through it, there's 25 columns, 6 rows. Oh, that's because it's the first 6. American Airlines, stock info, stock day value. You have the year, the month, year. The lag, today to lag, as you can see, this is lag 1. So yesterday's price was $19.30. The time interval taken was 2005, September 27th to March 13th, 2020. And the stock day value is 2050. Today's is, yesterday was 1930, so it went up. As you can see, it went up 6%. This is a ratio of the stock day to the price 1 day ago, which was yesterday. But then on this date, which isn't the next day, it actually goes down 2% or 1.5%. So, you could see these values through there with the whole table. And let's look at the other variables. So we got the today greater than lag 1. When it's greater than, it's actually keeping track of how many times was it decreasing. Today less than, it's keeping track of how many times it was increasing the stock value, the number of times that occurred in this time period that there's information for. Column names, there's 25 of them. I'll show you, we're not going to use all of these. I want to create a subset, so we're going to get, I just put S for subset and then the AAL, and then change the row names to be the date. I selected only these columns, the 5th, the 9th, and the 14th to 25, which is day of week, stock day value, and the 14th to 25, those ones. And I'll go ahead and run that. And then look at the class of all these variables, because sometimes, actually all the time, that really does depend on how your machine learning algorithms chosen will operate. And so these are integers, which is what we want. Eventually we'll use a different class. Stock day value is numeric, lag is numeric, today is a ratio, it's also numeric. Good. The days of the weeks are factors. We're not going to use it as a date. We're going to set the seed so that every time you run this code, it will be exactly the same, so you won't have a different result. And so this creates a training partition, which is going to take 70% of that file, which you'll see is 290,885 observations or rows. But actually the SAL stock is a subset of that, so it's 3,639 rows, and you will have 70% of that as a partition, and then it's going to put that in the training set to train the machine learning on, and then it's going to test it on the testing set, which will be the 30%. Yeah. Okay, so we can see that makes sense. 30% of 1,090 is about 30% of 3639. 2549 is about 70% of 3639. And there are 14 variables instead of 25 because we already excluded certain variables. This is the random forest mod. It's going to go ahead and have the defaults. I think the defaults are 500 trees. If you're uncertain, you can go to the train function, and this is the carrot package. you type it in the console, it's going to pull up an automated, it's going to say the caret function F1 because I'm in Microsoft Windows. And go through it, and it has a host of information. Random forest will expand this, and you can see it has all the details. If you want to do random forest method, random forest, X is a data table. Okay, so root mean squared, I was looking over this. Log loss, root mean squared error, log loss, the absolute mean absolute error. Okay. Accuracy is for classification. Root mean squared is for regression. I just read that yesterday. And then the method. Yeah, you'll find that data scientists have their own method of doing things because it's still cutthroat, so they want to make you look stupid. But actually, I read a book in my last machine learning class, and you try out different things, it doesn't work, then you test it out. And not anyone can do it because nobody really wants to do this if they don't know what they're doing, okay? So this will tell you a prediction accuracy for the results once you run the program. From there, you can tweak it by looking at the console, bringing up the package you use, train, going to the method, which we put here, random forest, and it's going to be using by default regression because they're numeric data that you're regressing these features on. And it's going to be, for this one, I think we are predicting that either the decreasing days or increasing days, and it will get pretty good at it. Not this first run though, because there's like different runs of it. So let's go ahead and use the random forest. Taking you through here while it runs. Yeah, this goes more into detail, scrolling down through the help menu. You can see method metric. The metric is the one where it will decide when you run it if you want to use classification or not. K-nearest neighbor, it shows you rpart, recursive partitioning trees, like decision trees in Python. The linear model, which is generalized linear machines, linear regression. Generalized linear machines uses like naive Bayes type linear models for regression. Also classification. And so it's still running. And yeah, feel free to go through all that stuff. I'm not really seeing what I saw yesterday, but you know, when you drive at night and you drive in the day, it looks different. So, all right, I'm gonna pause this. Oh yeah, so data scientists are cool and you want to be one. That's really great. I just want to let you know when you're going on interviews and it is cutthroat, you have people that want to make themselves feel like they are way better than you and they know what they want to do and how to do it. And oh, they're so much better than anyone who can do everything just that you do. Any flunky can fucking run a code. That's not true. And I've had one guy even say, you can't use decision trees on unsupervised data. Yes, you can, and yes, it does use rule classification. But if you don't want to use it unsupervised, then it has the unsupervised, which is like text or image data. Yeah, that guy was an asshole. And I've also had other people, men are not the exclusion, females as well. So just know what you're doing, and if you want to do this, this is a program I wrote, so you guys need ideas on what you need for a data science project, then go ahead and think about shit that you don't like in the world and how you can fix it. I'm a millennial. I lived through the regression and now I'm living through coronavirus. So coronavirus will be next as soon as I get information from the NCBI of the grant funded research that they're doing on the COVID-19. I should have it in here already. NCBI nlm.n.i.gov. Okay, maybe not. Well, you could just go to the gene expression omnibus while we wait for this. Yes, I've had many different stuff that I had ideas for. This is why you do data science, is to get the information so you can best answer a question or use a visualization. Yeah, sure. Okay, you might not know the exact tuning parameters right then and there to get the best results, but if it's within a ballpark range of over 80%, then it's pretty good. And from there, you can tune it. And you will have errors that you can fix on the spot. R will let you know because it will turn the text into red whenever it's not working. But about that. Yeah, I'm not going to make any apologies for that because I spent a lot of money on my education. I have met people that are assholes and then online. Online, they have professionals saying, it's not you, it's you. Nobody owes you anything. You know, it's like Instagram, like, I'm not going to blast anyone, like, personally, but you've probably seen it. And there's so many subsidiary companies that say, oh, get into data science, learn it in a month. No, you can't learn it in a month. If you don't know what you're doing to build the table and what the information is you need, you cannot learn it in a month. You have to have rudimentary skills that you learn in math, like linear algebra, calculus, even in computer science, what you're doing. My undergrad is in economics and math, and linear algebra was a big part of it. This is the grid search. They have also some great stuff on LinkedIn.com learning. And if we're just going to just, I can actually just scroll through the script right here. All right, so we could see the results. I actually have a PDF of it open. That was the other one. That was creating that stock. Okay, I don't need that one. Okay, so we had the random forest classification. Let me take you to the metric by default is regression. Sometimes with the data, when you look at the string of all of these columns, which are their features, it will show you in our subset what the class is. So make sure you're working with the right type of class, because when you go to, let's say, oh, this is one using Yelp. I had to change some things, but you can pretty much copy and paste the same code, but you will have to tweak it a bit by changing around. Like I did a round result, because when you do regression and it's not an exact numeric calculation for what it's trying to match, you'll get like 0%. But when you look at the data, you will see that it's within one unit. And if you're a math major, you know that even any value between 0 and 1 is infinite, because it can be infinitesimally small. So it will not be exact otherwise. And so I'm just trying to find it. I'll pause it until I found it. So we were looking at Yelp. I made a subset. And then going past the round one, you can see that RCO is still running. It's random forest doing 500 trees, so it's pretty good. It still doesn't take that long. Whenever I did a subset with Yelp, we were going to predict the next day price. Okay. And we did. Let's see. So we used the date as a factor. Okay. Then we go to partitioning it, that data table. We ran the random forest. We plotted the results. That just gives you the root mean squared error as you get more trees. And yeah, so let me just kind of jump back to where this was. Okay. So whenever I did, let's rewind. Okay, back for rounding these measures. Okay. Okay, so these are the algorithms I use. Random forest predicts by trees classifications. You see all the plots in like multi dimensions. We have 14 in this case for that subset, and it uses discriminants to just break it up into trees and do whatever, just analytically. Then it produces a result, and you'll get that result in a table. Let me just go ahead and pull up the PDF. I can do that by going to my files on RStudio, Maximize in this, and seeing the PDF of this new stock counts 65 ML PDF. And that is right here. Okay. I have it up and running. By the way, in cold weather, I think it's important to stay hydrated. And if you can't and you drink a lot of coffee or whatever and you don't drink enough water, this lotion is actually great. Because, you know, as a massage therapist, sometimes our hands get really dry and cracked, and we can't operate on our hand. So let's just take the lotion free. All right. Yeah, great. For sure. All right, we have the PDF file up. These are going to be our results. Our studio is still running on the random forest. I don't remember it running, taking that long before, but I also have the screen share on, and it does take a lot of my so I already showed you where all this stuff's going to be at on the internet. Let's go to this PDF. Okay, so these are actually the results. And yes, because if you put the table, you want to see it in RStudio, it's nice and pretty, and you can just scroll to the fields. But when you do print it out to PDF, if you don't put header tail, it will do the whole thing, and you'll get consequently a 1254 page file that you have to scroll through. What's great about technology is that you can just search for it, and we know that where we want to look in a script is, let's just say, results. We'll copy and paste that. And we will search for it. Actually, I don't think it does it in this version. I mean, it's not. Well, if I open up in Microsoft Word, it will. We'll just scroll through it. Let me scroll. Okay, I scrolled to something that looks like what we want. So it has the root mean squared error for cross validation. Okay, yeah, actually that was ridiculous trying to scroll through all those tables. So I'm just going to go ahead and search for what I'm looking for here in Microsoft Word. So I'm looking for results, and it will show me in order of where they are. Okay. So this is the other one where we rounded it. As you can see what I was talking about when it predicts the random forest, I created this table too. The accuracy was 49%. That's actually not correct, because if you look, it's doing the actual number of days. I believe we're predicting increasing right here. It says it right there. It predicted 0, but the random forest predicted less than 1. So I had to put in a threshold for that said if it's less than 0, 0, and if it's greater than or equal to 0, 1. So this will go to 1, but it won't be right. But right here, 1.046 is not equal to 1, so it doesn't count it as an accurate prediction. But if you round down, it is 1. So what I did with this next step is to round the results. And you'll see it right here, round it right there. And then you also round the type. And that's for the results on this table above. Okay. K nearest neighbor, etc. Okay, let's just root mean squared error cross validation. And okay, so we're gonna go to the predicting the number of increasing days of cycle for the American Airlines stock and random forest, plot the random forest, see the randomly selected predictors, the root mean squared error for cross validation, which is like the hold one out, and then test within the training set is 0 as you get more predictors past about 8. Now, going through the code and the output, we're in this case testing for the increasing days. We will see the values. You could see 8.54 was a predicted random forest number of increasing days, but it was actually 0. 1.5 is actually 15. 1.99 was actually 2, so that would have been correct. Now, if you go to 2.012, that would have been 2. These two are both correct. This one's correct, but it's not getting correct. It's not saying it's correct. Now, these two are wrong. Those are wrong. These two are right, but it's going to show that all of these are wrong. This one's not correct either. This one close. These are definitely correct. They're close to 8. All right, so you see what I'm saying. Okay, now when predicting the number of increasing days, why are there negative values? This is why I rounded, because it's going to 0. The correct day is supposed to be 0. The number of times it increases 0, but it had a negative. That was based on the random forest model, because it's basically saying that it wants it to be 0, but there's actually an even greater chance it's less than 0 based on the historical data that we have in our time series for American Airlines. So then I look at this and we want to know the increasing days and then removing certain vectors. This is a second subset of American Airlines. This is when I round it, okay, but the reason we're rounding is because accuracy is way better than it should be displayed. It is displaying accuracy that is not correct because according to its algorithm, if it's not exact, it's not correct. Okay, so actually it's done running. And that was the first one. Plot. See what we just looked at in the PDF version. Do not print out the entire, when you run this, whenever you knit it. In RStudio, it's in our Markdown file. Do not print out the whole table because this results table is huge and you will get a document with unnecessary pages displaying the table. So I'm going to close that out. I'm not going to save it. We're going to go back to RStudio. And now we're going to use that model we just trained on our subset of American Airlines to predict the number of increasing days. We'll see the accuracy. And as I just showed you, 49.8% is not very accurate, considering a lot of these values are pretty much the correct value, except for like a few of them. So we're going to change some things up by showing the next one will be the results. But let's go through the other three models. K nearest neighbor, train that on the data set. It gets the closest neighbors, and whichever one it is one type and the next type and the next type. If there are more that are one type, it will choose to make that sample that type. So it's basically on a voting. So K nearest neighbor. My K nearest neighbors are politicians. I'm a politician. But I'm not. I'm a service worker. But sometimes it can be pretty accurate. So it's then doing that. And it should plot it. But the graphics card is probably being used up by this screen recorder. And so we have the plot, root mean squared error, cross validation. As you can see, the more neighbors it has, the higher the error rate. But at 5, it's pretty low. So whenever it does 20, there's too much variation. But 5 is pretty good, decent. Now let's do the recursive partitioning trees. And it will be, all of these are predicting increasing days this cycle. Let's do the generalized linear machine model. See that result when we use those models that were built to predict on this data set. And let's get the GLM prediction. Let's get the number of observations. And then let's get the accuracy. How many were accurate of those three models? And we'll look at that. We'll see the results. This is not the rounded version. And we can see how pretty it looks in RStudio, but when you print it out, it is a mess. So we'll go to the true value, number of increasing days. You can see the GLM was actually pretty accurate too for these values that it predicted. It is pretty close with random forest. K nearest neighbor, not so great on some of them, but some of them it's pretty close. 15 is actually pretty close. That's pretty close. So the discriminants, you could tell if K nearest neighbors are a pretty good measure to classify or actually regress and predict the true value. This negative value right there means that it's most likely, it's like greater than, I mean, it shouldn't have been 0 even before that, but if it could go beyond 0, then it would be that much more unlikely that it's increasing, that it's most likely decreasing. Okay, so when you scroll through, you see the true value, and that was the last of it. There were 1,091 rows in our training data, testing data set, and 5 of those columns. Let's go to the rounded one now, which is basically we're using the same exact models, but now we're predicting it on the table, but we're going to round the results. So it's actually, we didn't actually predict anything really. We're just using a logical so that if it's less than 0, it's going to be 0 for those negative values. And then it's going to round with no remainder. So we run that. We get the results for the random forest one first, as we did before. You can see how it jumped to 99.9% accuracy. 99.9% accuracy when we rounded the values. And you can see this is very good because it's actually a good way of modifying this table of results so that you can see the bigger picture here. Because if we were going to buy it, we want to know, is it still increasing? Because then we're buying it lower than its actual value. But if it's decreasing, then we don't want to like buy it right now. We're gonna lose money. And so got the results. When you round it, it makes a difference. Let's go ahead and see it. Yes, the whole table. Random forest next 100. You can see, yeah, 1091, you can see a side-by-side comparison. This one looks good. Let's just try 96. Yeah, they're almost all right on, just like they should be, because 99.9% of them are right out of 1091 observations. Now let's do the k-nearest neighbor. I too find it distracting looking at somebody's face while you're trying to learn coding. But for some reason, in most of those tutorials, they say, people want to know they're talking to a person. Not really. I don't really care either. Okay, so we have the k-nearest neighbor rounded. Let's do the recursive partitioning through. For that. And then you can just basically see like a side-by-side comparison of what's going on. Generalized linear machine. Let's predict now. And we went ahead and did the logical, so that if it's less than 0, it's going to be 0. So we're not going to push past that point. And number of observations. The accuracy. Let's just restore our environment, and we can see all these being populated in our environment. They will be down there. And so we will go ahead and create our table to look at the results. And we'll just go to the last page. And so those are the rounded results. You can see they are very good. K-nearest neighbor not so great though, because there's a 3 right there, and everything else is a 2, 4, and everything else is a 3. But some instances, it's pretty clear they have the same result. And so that was the original table. And so you can see why the accuracy was not so great. But you can see how I got there. And so if you were going to use that, you would have a 99% chance of knowing if it was going to be on an increasing day cycle. That doesn't really tell us much because we want to know, is it going to increase tomorrow too? So we should go to where I use that part of the code to do that. I use different features when I did that part, but let's just walk through it. So there's about like 5 to 7 models here using American Airlines and Yelp. There's about 3 to 4 of American Airlines. And this one I removed some of the features, which shows you how feature selection can improve or make worse certain predictions. We're still going to be predicting the number of increasing days. I'm just going to run that and show you the results. Oh, and this one, these are the features we're using. We're using day of the week, the stock day value, the price yesterday, the ratio of the stock day value to the price yesterday, which means it increases if it's greater than 1. The increasing days this cycle, which we're using as the target variable, and the number of times in this time series that exact value of increasing days occurred, which is going to be part of our features used to predict our target variable. Set the seed again, training set and whatnot, random forest. Now in this case, we see that with fewer features, randomly selected predictors, the root mean squared error in cross-validation goes down. That's great. And then we predict the model. Again, we're seeing what we saw before when we didn't round, which is that -7 should be 0. This is 1. So we do get a low accuracy because we haven't rounded the outcome. And then we can look at the results side-by-side comparison for all of these 1091 observations in our testing set. Got the k-nearest neighbor. It's basically the same thing we just did, but it's using less features. See if these are better. But keep in mind that it was a 99.9% accuracy in the other one. Our k-nearest neighbor plot looks as though it's about the same. You know, good about in the 5 to less than 10 range, and then the error just goes off the charts with more neighbors. Makes sense. The results of all 4 algorithms pretty much the same in different numbers, but we're going to go to the round part next, which will be rounding off those predictions to see if it can beat 99.9% accuracy with fewer features. Well, right off the bat, it didn't. 98.89%. So that's pretty close to 99.9, and it had less features, but it was faster. So that's rounding with random forest. And we can see the side-by-side comparison of predicting the increasing days this cycle. Alright, GLM didn't do so great. Look at that. rpart got pretty close. K-nearest neighbor didn't do so great in some samples. And the random forest. Alright. Last day. Okay, last observation. Results. That was the original table. Alright. And okay, so these were the results rounded 99%, random forest, k-nearest neighbor 80%, recursive partitioning trees 91%, generalized linear machines 45%. And of course, the increasing days true value is 100%. I went ahead and added a column to this table that would show which algorithm predicted the result the most amount of times based on this loop of if else's. That was a separate measure for if it's a random forest identically equal to k-nearest neighbor, then it goes into that loop. But then it's also or if it's equal to rpart or GLM, and then it goes in there, and then if it's equal to any of those three, is k-nearest neighbor equal to rpart? Then if it is, and then it's like a whole bunch of inner loops and stuff like that, nested loops. And we can see that the ACC most gives 91.2% accuracy as the most voted from the fewer features data table. I went ahead and wanted to combine the training set that the model was built on to test on the training set so that it could give the results and combine it. But to my surprise, the results were actually worse, which it built the model off the training set and tested it on the training set, but the outcome was worse than using it to predict the testing set results. And so we see that the accuracy is 36.5%. You see the side-by-side values. I mean, some of them are good, like that, this June 16th, June 24th. Some are not. June 10th and 13th, the 30th, and so there's more of those. According to this, there's like 64% of the training data set is wrong. A side-by-side comparison of that training set with the results. This are what should be the value. K-nearest neighbor and rpart actually did pretty good for the first few. rpart actually did better on the training set. Actually, it was completely true side by side. All the values are correct, but generalized linear machine, random forest, k-nearest neighbor, not so great, especially random forest when used on the training set that built it to predict the training set. Interesting. It generalizes better to the testing set, which it's using for the rules that it created in the boundaries discriminates to categorize, classify, and regress, or regress, depending on what mode you put. And so for the next model, after combining the most devoted and showing the head and tail of that, and then looking which one was the most devoted, or look at these results. You can see random forest 37%, k-nearest neighbor 81%, recursive partitioning trees was 91%. As we saw earlier, it was side by side the exact same values on that one screen. Now these are the training results, the testing results, which is what it generalized better to. And you can see random forest was great, 99%, k-nearest neighbor 80%, recursive partition trees 91%, generalized linear machine not so great, 45%. Now getting back to why I originally wanted to direct this vlog to. By the way, I'm wearing this robe because everyone lately has been wearing a colorful robe in their vlogs, so I figured I'd. Okay, so when you pull up that 65 stock data set that we made in the Matrix Automate and the version 2, which is right there, and that takes about 20 minutes to pull it in here, and then after you read it in, you're looking at which stocks you have information. You should have information for all of them, not the same dates, the unique stocks. Select one of those stocks and run the same program on it. It just happens I chose Yelp for the next model building. And in this one, we have Yelp. Okay, I'll go through it and then I'll explain. So Yelp is also a stock that does not have information going back as far as 1999. It has information from 2012 to 2020. The number of days are numeric or integer. There are factors from the date types. And we're not going to keep all of these features. So in this model, we have decided to use certain features to predict the number of decreasing days. I'll show you the outcome with our regular version and the rounded version. We can see right away that predicting the number of decreasing days this cycle with the number of features we selected, the root mean squared error goes down, which means there's less variation and more accuracy the more predictors are randomly selected. But we also have the same thing with the exact value not being met. So we get 30% accuracy. Yeah, 30.1% accuracy in predicting decreasing days, but we know that's not true because we don't want the exact values. We just want it rounded. So we'll do that. And we can see k-nearest neighbors, the more neighbors, the less accuracy, because there's just not going to be a good classification regression with more neighbors when we're trying to predict the number of decreasing days based on those features. And it's actually doing regression because it's numeric. It's using the numeric data and the other class code categories. We're just looking at a side-by-side comparison of all of these values, the true value. And you can look very close, ballpark range, at all those values for predicting the number of decreasing days. But actually it did round to, I believe, 7 digits, and recursive partitioning trees, even without rounding, got 95% accuracy in regression prediction for the number of decreasing days. Not too bad. But the next step will be to round it, and we'll see how that compares. When rounding, it compares nicely. The accuracy is 99.2%. And the side-by-side comparison for random forest, that's random forest accuracy, is right there. Let's look at the others. So decreasing days of cycle when rounded, 99% accuracy, random forest the best. Next is recursive partitioning trees with 91. Then generalized linear machines, 81%. And then k-nearest neighbor, 80%. This means that 99 out of 100 times, it's going to predict if that's going to be a decreasing day this day, if it will decrease 99% accuracy or 4 out of 5 accuracy. And this is a table of the results without rounding. It was not very good, but recursive partitioning trees did do good, 95%. And now we get on to the next day price, because this is what we're interested in. Tomorrow going to be a good price? Like, can we predict tomorrow's price? Will it be higher or lower than today's price? Should we buy it or not? Because we already know with up to 99% accuracy if it's going to be an increasing or decreasing day. So then from that, we can say, are we going to buy or sell this stock? And then given that information, let's use the lead function, which will give you what the next day's price is, and compare that to today's price. So this is what that does. And we will be predicting what the price is. And this will again predict the exact price. It will seek to predict the exact price and then give you an accuracy measure. And I do believe all of these are 0 because it just doesn't do it right. Or it's very close to 0, like 13%. But we fix it and we get a good price in the end. This is where we start getting into our model building, which uses the factors for if it increases or decreases by 2%, but not in this model. So I'll just run it and explain. So we have our lead price, which is the next day price. If you compare that to today's price, stock day value, 20.99, 20.50, you'll see 20.50 will be in the next day price for this date, March 5th, and 19.80 will be in the next day price for March 8th. This is the original table, 19.80. And then, 20.50 for the other one. Okay, going back to the code. We created our partition 70%, 30, that's standard. For the training set, 70%, testing set, 30%. We're going to run the random forest, k-nearest neighbor, recursive partition trees, and then generalized linear models. Okay, yeah, so we are still trying to predict the exact value. As you can see, I told you it was going to be 0. But the prices aren't too far off. Look, it predicted 21.85. The price was 22.99. 23.44, 23.22. This is a random forest class regression, so yeah, we can make this better in a way. Exact values, not so great, but I do believe generalized linear machine does better in prediction accuracy. You really don't want to go with a model like this, though, if you want to predict the next day price, if it's going to be, I mean, 22.99, I mean, and then 21.85, that's a little over $1 off. And so we will go through this code some more. These values are actually the next day value because it was for the lag 1. So I mean the fluctuations based on the data that we provided for that time series, and then we also use the number of increasing and decreasing days as features for predicting the next day price. Not too bad. Again, k-nearest neighbor doesn't do so great with error as you get more neighbors. And this is a side-by-side comparison. The next day price is the true value, $22.99. Which one got closer? It's kind of like Price is Right. Like if you're over, under. So yes, not really describing a lot. The next model decided that we want to test out if rounding this next day value will result in better accuracy if we round off the other model predictions too to see which one predicts better. Let's see the results. And when we do this, the random forest gets 51.3% accuracy. And we can see the side by side, which isn't very good. The exact price isn't very good. So it predicted 22. Next day price was actually 23. 23 was predicted. That one was right. But this is a regression. We'll see the side by side results next. When looking at a side-by-side comparison, generalized linear machine and random forest did do best in predicting the price. Random forest actually was the best with 51%. This is rounding the values. And that doesn't really tell us much. In fact, we can't really use this model. But we know a range, which is basically what regression does. It gives you a confidence interval of the range of values. And then it will predict based on those previous data points and the mean and the variance and all that gets worked into making those predictions, except they have a different method of doing it. Random forest goes by recursive, well, it goes by trees and discriminants. These are basically the same measures they use for classification. Generalized linear machine is a traditional logistic, naive Bayes, or linear machines that they use in this type of algorithm to predict the exact price, which is price forecasting. Those were the previous results. You can see the way that they predict numbers off to the, let's see, 16 significant places. This is the head and tail of the table for the predicted prices and the next the actual price. I didn't remove the column, so these are actually the same value when merging the testing set with the results from the Yelp. I went ahead and added a most voted number using the same if else type loops, and the accuracy was 45% with the most voted. So most voted it chose 28. That was selected twice, but the next day price was actually 27. If random force got that. Oh, random force did got 27. Oh wait, yes it did right here on that one. Random force is usually a very good predictor. In the first Netflix price, random forest was the algorithm that. Okay, so this one is when we start to use the factor because we want to predict because we weren't getting very good results with the next day price forecasting. So we want to say, will the next day price increase by 2% as a logical? 1 is yes, 0 is no. But we want to make this a factor too, so it does that. And in this case, we will not be regressing the values, we will be classifying. And this is where you type in train to see all the functions, and then it pops up. You press function F1 in Windows, that's what we're using. And then it would populate the help menu that we saw earlier, which is right here, explaining what those algorithms do and the metrics to get classification versus regression versus unsupervised. All right, I'll run that and explain. So this is where we're getting it over 2% because if we have a next day price ratio to stock day value, so if the next day price to stock day value is greater than 2%, it'll be greater than 1.02, and it will be a 1 if yes, a 0 if no. We're going to remove, let's go ahead and make that, because we don't want to keep in the next day price because then it's going to just predict whether it is or not based on information that it's given. We want to hold that information out, so we're going to keep that line of code in there so that it gives us a better result based on us wanting to know if it can predict the next day price more than 2% without being given the next day price. And that is the 10th column in the table in SYelp1, the sunset Yelp. You can see that from right there. Because there are 10. Yeah, because we just ran the code, so yeah, I got rid of it. But before running it. So if we were just to go right there and run that line, SEL1 before removing the 10th column, should have had 11 columns. And it does. Yeah, because I need to add in the next day price column. And so we'll run that and okay, get rid of the date, make that the rows because we can, because it's not all stock. So let's run just those selected lines. And we remove the date column, 10 columns, next day price, and then we had the next day 2% logical, and then remove the next day price. So at this point, it has 11 columns. We run that and see that it should run it. I don't think. Yeah, 11 columns. So we're going to remove this 10th column, which is next day price, so that we're not predicting whether it's going to increase or not, because it has that information and it's not really predicting it. It would find that it's in a calculation for the stock day value. You would see that in common, and then also the next day price. It's almost algorithms, and that's what we don't want. That's why we're removing it. All right, so let's just run that whole code. I'll show you the results. Okay, it has partitioned into training and test sets. This is a smaller series than the American Airlines. Testing set has 605 samples. Training set has 1414 or 1414. These are the two models that could be used differently. They have different parameters. We've just been using the carrot package, so we'll just keep using that. Oh, actually, later on in the script, because I go back and forth between it, there is a problem with the random forest because this next day 2% increase wasn't found. So we're going to go and comment out the next day price because I wanted to add this in at the end of the table, at the end of the script run. So we'll comment this back out. So this in there. But we will be removing it in the testing and training sets. And as we can see by looking at the screen, it is much better in predicting if the next day will be a 2% increase or not. So we can look at this side by side. Okay, this is a case where it's not match also right here. And but I mean, for the most part, actually this is terrible. Those cases. That's not really a good fit. There is actually a better model, so we're gonna run the other models. Apparently it got 80% accuracy. So 4 out of 5 of the days, you can predict if it's gonna increase by 2%. I'll be right. The other day, not. All right, so let me just go over something. This metric was added. It wasn't in the other ones because accuracy or kappa is to use for classification, not regression. Otherwise, you'll get a message you've never seen before that says, are you sure you want to use this on less than 5 parameters for the target? Because you should be using classification. And then it'll repeat it and repeat, repeat, repeat. But I don't have an image of that because you really don't want to see it. I just want to let you know, though, there was a change made. And I made it. It was with the metric. And that was added because we do want to classify. I do believe random forest, the same metric was also added to it. And actually, that metric wasn't added to random forest because it didn't throw anything, because it automatically does. It chooses by default classification or regression. I just went ahead and changed it to a factor instead of numeric because originally it was numeric. And this is where I changed it to a factor because that's what we wanted, the factor. So the random forest picked up on that. And these are the values that it predicted: 2 levels, 2 classes. Yes, yes, it increased by 2%, or no, it didn't. The 1 is yes, 0, no. Okay, so just so you know, if you do decide to do this, you'll be right 4 out of the 5 times. You can't hold me accountable. I'm just a data scientist. I'm not your financial advisor. If you want to run the program, you feel free to do it. You know, if you want to make extra money, right now is a great time because all the stocks are going down in price and they always go right back up again. As you can see from the whole time series, you can do the start and final value and see that every single one of them increased or at least stayed within the same amount, except for the biotech stocks. But right now, because this is a biological problem, those could actually have their up cycle. They were falling before, but now, I mean, they invest heavily into cancer treatments and advanced research and development, so their time might be now. I'm not your financial advisor. I am a data scientist. And it is up to you, even with the abusive language I've used in this video blog, to decide if you want to use it or not. You can just test on E-Trade, get your own account, have your social security number, bank account ready. I just experimented with $100. I most likely lost it, but not all of it, because most of them were, I feel like the biotech would be good to invest in right now, and it's just fun money. E-Trade, etrade.com. Feel free to have fun with it. Quit your job if you do good. This program, so far, it just to tell you what it did, you will have to stay tuned for the recap and takeaways. But just to see what we're looking at, you can see that 80%, 80%, about 80% for the other 3 algorithms. So, I mean, you're going to be right 4 out of 5 times, you know, if it's going to increase by 2% or not. You're also going to know if it's on a decreasing cycle or an increasing cycle so that you can make your decisions on what stock to buy. And you can only choose from these 65 until I alter the script in the stock 65 basket. So, to recap, this taught you how to use my script and where to get it, and the table on Kaggle that's about 60 megabytes. It also showed you how to get your own information with using the script, how to automate it, use the date, use the previous time lag, get the number of counts using that script. That will take about 20 minutes to run. Then you pull it into this program, and then you pick which stock you want to look at. Now, it does not account for this time period right now because this is completely different. We're going through a government type shutdown and economic recession, which was forced because of this coronavirus. And it is a deadly pandemic, and we haven't had this in our history ever. But as an economics undergrad major, I can tell you that we were on inflation. We had a lot of supplies. And when inflation goes up, a recession is bound to happen because the banks increase their rates. And because of this, the banks have decreased their rate to 0. Can't do better than that. So businesses want to borrow. Thing is, we have moratoriums on rent, but you still have to pay the rent, so you have to get back rent, and this will put back people. A lot of the times, people have lots of money. The same thing goes with repression, suppression, like being confounded and bound. Then they're going to go out and they're going to travel even more. They're going to spend more, and this and that, because they don't know what they're doing. And they just want to forget about what just happened. And then there's also the people that are poor and can't afford shit to begin with. And so they realize that, hey, they don't make enough money to survive these kinds of pitfalls in life, and they still have to work even harder afterwards. There's going to be problems with the amount of pay that unions and government organizations take, and then how they hoard supplies from the poor people that need them. I'm not complaining because I've seen it happen based on a case system where most of the people that work in my field of training, they really don't look at massage therapists in the same regards as a colleague. And I have the skill. I'm very smart. Okay. I've had great teas that were Indian, but they weren't from that Third Reich. Okay. And those ones are the ones that will not hire you if you come from a key system of any service industry. So, because they do not respect you as a call. I've seen that. Message me and I'll tell you where. So getting back to the takeaways. This was a vlog. Run the program, get the dates that you need, get the lives you need, run it in here, find out. You can tweak these algorithms as well. I didn't really do that so much to get better accuracy. Once you get more data on maybe the next 3 months for how the economy does in a pandemic of this proportion, the recession we have forced ourselves to be in, not by choice, government regulations, and because this is a very high mortality rate disease where it recently said 168,000 cases, 68,000 recovered. I mean, that's not very good. That's around 30 to 40% recovery, which means either the other 60 to 70% died or are still trying to get over it. It's not great. So they shut down businesses for at least 2 weeks. And most likely, I mean, when there's civil unrest and war, outside forces can attack, and it's not good. So, I mean, this could just be something completely wrong, and then external forces outside of normal day to day can't really have an impact on how this program is. It hasn't accounted for that. It's only up until um, kind of like the beginning of the pandemic. So you can predict the number of decreasing days, number of increasing days by stock. You could also forecast the price, but it won't be very good at doing that. And you can also predict whether it's going to increase by 2% or not. You can also add your own features to it. But that is a takeaway. And feel free to use it. Stroke my ego.